Happy Labor Day weekend, everybody. At the end of class on Friday, I said I would make a short little video. I'll try to keep this short, of just summing up how we write the solution to a system in vector form. This is the example I gave at the very end of class and went through it kind of quickly. We were pressed for time, so I just want to take my time and set up the vector form of the solution. What we did was we went back to an example from section 1.2, a system of equations that we solved. And back in 1.2, we got to this point. We expressed our answer in this way. And we're not going to write our solutions that way anymore. We want to get used to writing solutions to systems in vector form. So there are 6 variables involved here. So it's a vector with 6 components, actually an element of 6-dimensional space, R6. And the free variables I just recopy, so x2, x4, x5. The variables that are not free are either expressed in terms of the free variables, like x1 and x3, or they're equal to a constant, like x6, which is just has to be equal to 1/3. Now, in order to break this up into a clearer vector description, just notice that we're going to have an x2 term, x4 term, or we have these terms involved, in x5 term. And we also have, separate from x2, x4, and x5 terms, we also have a constant, and a constant term could appear in any one of these equations. So I'm going to, once you get the hang of it, you don't have to write this next matrix, but I'm just going to do it for emphasis here. And I'm going to write each one of these components using 4 terms. And the first will be a constant term, then an x2, an x4, and an x5 term. So there's no constant term involved in the first component, so I just write 0 minus 3x2 minus 4x4 minus 2x5. And the x2 by itself, where there's no constant, that's like plus 1x2 plus 0x4 plus 0x5. So any term that's not represented would just contribute a 0 coefficient, right? So x3 is 0 plus 0x2 minus 2x4 and plus 0x5. x4 is 0 plus 0x2 plus x4 plus 0x5. I think you get the hang of it so far, but I'll keep going. 0 plus 0x2 plus 0x4 plus 1x5, or just x5, that 5th component. And then the 6th component you can think of as being a constant. Now, it's certainly possible that many of these could involve constants, right? In this example, we just get a constant from the 6th component, but there could be many more in other examples. So I have 1/3 plus, and now the free variables are not involved, so it's 0x2 plus 0x4 plus 0x5. And so now I can break this up into a sum of vectors. I have 0, 0, 0, 0, 0, 1/3, plus I'm going to have a vector involving the x2 terms, negative 3x2, x2, 0, 0, 0, 0, and I'm going to have a term, another vector for the x4 terms, minus 4x4, 0, x4, negative 2x4, x4, 0, 0. And another vector term for the x5 terms, negative 2x5. And this is going to be 0, 0, 0, 1x5, 0. And of course you don't have to write it out in this much detail. But I just want to make sure this was clear to everybody. And let's take it now to our one step further to get our final form here. We have our constant 0, 0, 0, 0, 0, a third. Plus, now from the second vector, I can factor out a scalar of x2 times negative 3, 1, 0, 0, 0, 0. Then I can factor out from the next vector a scalar of x4. And so I have negative 4, 0, negative 2, 1, 0, 0. Plus, factor out an x5. And that will be times negative 2, 0, 0, 0, 1, 0. And so here's a vector description of the general solution. We really should say along the bottom where x2, x4, and x5 can be any real numbers. There are infinitely many solutions, but they all can be described in this way. It's actually a three-dimensional subspace of R6, but let's not go there in this video. So here's our vector form of the solution, the general solution to that system that we solved way back in 1.2. We really want to write our answer this way from now on.